Okay, we're going to look at some bigger matrices here and their inverses, some 3x3s and stuff, but before I do that I want to verify from the last video that the two matrices, the A and the A inverse that we found a moment ago, are actually inverses of each other. So the matrix I used was 1, 2, 3, 4. We found the matrix. I was claiming it was the inverse, but I never really verified it to you. We found this matrix -2, 1, 3/2, and -1/2. And I just said that that was the inverse. But I should show you, prove to you that it is. So to do that, you're going to simply multiply those two matrices together using matrix multiplication. 1, 2, 3, 4, and -2, 1, 3/2, -1/2. Doesn't really look like a 3. There we go. And now remember, when we do matrix multiplication, and this is probably a good review, you're going to multiply by rows and columns. Okay? So you take the first row, first column, and multiply those together. So we get 1 times -2. I'm going to write this out. First entry times first entry. And then second entry times second entry. So that'd be 2 times 3/2. And that'll be the first row, first column of the answer. Then we do first row, second column. So we go 1 times 1, and then 2 times -1/2. Okay, so first entry, second entry, second entry. Then we go second row, first column, 3 times -2, and 4 times 3/2. And then we go second row, second column, 3 times 1, plus 4 times -1/2. And upon simplifying this, I should get the identity. Let's just see. This becomes, let's see, -2 plus, let's see, 2 times 3/2, the 2's cancel. You just get 3. Then we get, let's see, down here this is -6 plus, here the 4 and the 2 reduce down. 2 times 3 is 6. Over here I get a 1 and a -1, and down here I get a 3. 4 and 2 reduce down, that's a -2. And if I go through and finish that off, -2 and 3 is 1, that makes 0, that makes 0, and that makes 1. Okay. So the product of A with A inverse is equal to 1, 0, 0, 1. That's the identity. And if you were to reverse the order, I won't go through all the details, but if you reverse the order, you'll get the same matrix. Okay? So that's just to verify that for you. Okay, and to get a little bit of a review with that matrix multiplication. Okay, so while we're on this topic, we're going to take a larger example. This one's going to be a 3x3, so we're going to find the inverse of, let's do 0, 1, -3, -7, 2, 1, 7, -4, -3. Now, with these larger matrices, I don't have a slick way to do this by hand other than the row operations like we saw before. So on this one, I'm actually just going to recommend one of two. You could either plug this into your calculator using the matrix. It would be the augmented matrix, just like we saw with the 2x2 case, where you put the identity on the right hand side. So it'd be 1 0 0 0 1 0 0 0 1, and then you go through and do the RREF process. That's a lot to type into your calculators, however, and I would recommend probably not finishing it off that way, although you could, it'd be no problem. My personal preference on these is to just plug in that matrix to your calculator, the A matrix, not the identity on the right, just the 3 by 3. Okay, and then do the A inverse directly on your calculator. So we could run through that real quickly here. Oops, clear that out. Go to matrix. Now I'm going to go to edit, and I want to do a 3 by 3 and type all these in. 0 1 negative 3 negative 7 2 1 7 negative 4 negative 3. And if I go to names, if I grab that matrix A and hit the inverse button like we did before, I might want to fraction this one right off the bat. So I'm going to hit math and then fraction. Alright, and this one actually does give you quite a few fractions. And so the inverse, if I write that in, let's put that down here. It's going to be 1/28, negative 15/56, and negative 1/8. Then I get a 1/4, negative 3/8, and negative 3/8. And then negative 1/4, negative 1/8, negative 1/8. Okay? Perfect. Now, I'm not going to go through and verify this one, but in theory, if you were to multiply these two together, you should get the identity matrix of size 3 by 3.